Um, we're going to go ahead and get started right now. First of all, please excuse my voice. I'm a little under the weather today. So if you can't understand anything I say, please let me know. And with that, we will get started. Make sure that your microphones are all muted. And if you cannot hear or see anything, you can use the question and answer tab and let me know. Once again, just a little housekeeping. All speakers on, all microphones off. At the top, there's a Q&A tab. Use this to ask me questions. I'll try and look up occasionally and see if there is a question and read it throughout. What I found helpful the last time was I exported all of the questions that were asked between the morning webinar and the afternoon webinar, and I answered all of them and sent them out in an email so everybody had them and had reference to them. So I will be doing that again today. And there will be a recording of this session, and a copy of the slides will be posted on our website, and I believe they're also sent out in an email to you if you've registered for this webinar. So to give you a little bit about what we're going to talk about today is that it is important that a plant does not encounter spurious trips, therefore disrupting the process and losing time and money. Even more important is preventing the occurrence of an accident that could result in a loss of your plant, damage to the environment, or even a loss of life. This webinar, we will discuss how calculating the spurious trip rate is important and what can be done with that number, saving you time and money. We'll also look at the dangerous detected failures and how those play a part in the safe failure fraction calculation and how they compare to spurious trips. We're also going to be talking about how simple mechanical devices and or final elements can still take part in a SIL rating by the means of the 2H method of evaluation without adding additional safe failures. So a little bit about me. My name is Lauren Stewart. I graduated from Virginia Tech, and I started engineering in design and manufacturing. After that, I started working at Exida as a safety engineer and consultant, and I work with majority of mechanical customers here. I also have done research projects, white papers and reports, and I've helped create and continue collecting data for our 2H initiative database. So a little bit about who Exida is. We were founded in 1999, and we grew to have offices worldwide. So anything with functional safety, we are your worldwide experts. We have four main focuses in the industry. We have our OEM, which involves certification, management support, and development support. We have our system designer section, which we look into self-verification, FSM setup, and other tools. We have our end user segment, once again, SIL verification, SIL and device selection, security audits, and we have tools for that as well. And finally, our engineering contracting segment, which has competence development, our FSE program, training, and once again, tools for that. So these are our main product and service categories. Our consulting, we do process safety, so we're consulting in 61511, 61508, 62061, and 6262, 62626. I always do too many of those. Along with alarm management and control system security. We also have a bunch of different engineering tools, whether you have Excellencia, cell selection, cell verification. We have our safety case tools, our FAMIDA tools, and our alarm rationalization tools. And then we go ahead and certify products. We have functional safety certification, which is the 61508. We have control system cybersecurity certification and network robustness certifications. We also train. We can come to you, you can come to us, whichever you would prefer. We do training in process safety, control system security, security development, and alarm management. And we also have reference materials in databases, textbooks, tutorials, and market studies. And finally, we have our professional certification, our CFSE, that's Certified Functional Safety Expert, and Professional. So anything dealing with functional safety, the processes, the products, or the people, we have you covered. Quickly, a little bit more about our products. We have different software that you can buy from Exida. We have our FACS, we have Excellencia, our safety equipment reliability database, our cell alarm for alarm rationalization, and our CILSAT, which is collection and analysis of operation and maintenance safety data. And a little bit about the CILSAT tool, which is the event database. It creates field failure events, creates a database for you, and maintains it. And it does everything you need it to. It can import data from other Excellencia applications, and it uses the Exida's predictive analysis tool, and its output reports are compatible with PERD. In our reference material, just quick bragging, Exida has authored most industry references for automation safety and reliability. And we have industry data handbooks on equipment and failure data. And we've also authored the most comprehensive book on functional safety in the market. So now to why you have come to this webinar today. To learn about how safe failures aren't always your best friend. Today, we're going to talk about safe failures. Are they your friend or your foe? How to use the safe failure rates to your benefit. How dangerous detected failures affect your plant. Calculations using safe and dangerous detected failure rates. How simple mechanical devices or final elements can participate in SIL with low or no safe failures at all. And 2H, what is it, who should use it, and how do you use it? So I'm going to start off by letting you know why I came up with this webinar. I was at a trade show a couple weeks ago, and someone came up to me and said, "Oh, we don't like your type of work." So, of course, I smiled at him and asked why. He started venting to me and told me stories about his plant shutting down so often and losing money and so on and so on. So this man, it was his idea that functional safety meant him losing time and money, and that Exida and other functional safety companies want spurious trip. So in his eyes, we're the bad guy. So I kept my smile, and I told him that at Exida, we don't want you to have safe failures. We don't want to shut down your plant. We don't want you to lose money. And you should have seen his face. He was in absolute shock. Then I continued, but we really don't want you to have dangerous failures. We really don't want an explosion. We really don't want a toxic leak. And we really don't want people getting hurt, or even worse. So let's work together and make a plan to prevent dangerous failures, but also the spurious trips. So these safe failures or the spurious trips, are they your friends or are they your enemies? Of course, there's pros to safe failures. They help increase your safe failure fraction, which if you're trying to get a SIL2 or a SIL3 rated product, that's something that in the 2000 version of the standard you needed. Now in the 2010 version of the standard, it's not needed as much anymore, and I'll show you the ways we deal with that. It shows your system is working properly, and safe failures are, let's just be honest, they're better than a dangerous or an undiscovered failure. The cons, of course, are pretty obvious. They shut down your process, you lose time and money, and even worse for some of you, you have to document it and investigate why it happened. So, how do you use safe failure rates to benefit you? By calculating the safe failures, or the lambda S's, in a company, you can A, lower your safe failures by changing the system's architecture to 2 out of 3 architecture. You might be thinking of, yes, that's more money up front, that's not what we want to do, but if you think of all of the time and money you can save by not shutting down, not doing the documentation or investigating it, you're actually, most of the time, you'll end up saving your plant a lot of money. And some of you might be asking why not a 1 out of 2 or a 1 out of 3. And actually, the 1 out of 2 and 1 out of 3 architectures increase your spurious trips. So in the investigation of this webinar, it's not a good thing. And also, in calculating the safe failures, you can find and lower the mean time to fail safe. One of the main reasons that you want to find your safe failure rate is you don't want many spurious trips. You don't want to be shut down all of this time. And if a company is experiencing too many of these at one time, the company will sometimes bypass the safety system. For example, one of my coworkers was on a plant tour, and right away he noticed that the safety system was completely bypassed. And of course, this is a huge red flag. The plant manager had too many spurious trips, and that was his easiest way to deal with the situation: bypass the safety system. And unfortunately, this happens more often than anyone would like to acknowledge. Sometimes it's bypassed by wiring. Sometimes it's bypassed by rerouting the piping. And once we've even seen it bypassed by a piece of wood. Really? A piece of wood? Well, I guess that's one way to make a gate valve stay open, just shove a hunk of wood under it and it can't close. But what happens if you have the safety system bypassed and you have a real dangerous failure? What happens if the plant needs to be shut down or the process needs to stop? And that's when we have a major problem. So if you calculate your safe failure rates, you can use that number to spend less time down, less spurious trips, and lower your mean time to fail safe. When you're talking about safe failures, you also need to talk about dangerous detected failures. If you get a dangerous detected, great. You detected a dangerous failure. That's awesome. But your process is still down. You're losing time and money being down. You have to document the failure and investigate why this is happening. And now you also need to figure out how you should do things differently so this does not happen again. And in most cases, this is bad, or actually worse than a spurious trip because you had a dangerous failure on your hands. Dangerous detected failures. Where does that number play a part in? It not only plays a part in your safe failure fraction, but it also plays a part in your probability of failure on demand calculation. And This calculation includes a system architecture. So when you're figuring out and you're doing modeling of a complex system, maybe a 2 out of 3 system, you can do it in such a way with software such as Excellentia so that it can take into consideration, okay, the average time of to restore and to repair this issue or this problem is this many hours, and it's including how long it took you to detect that. So removing that from your process, it includes the time that your safety system might be completely down and your process still running. If you have a 2 out of 3, it takes into consideration that the one leg of your safety system is still running, and it can run on only 2 legs now. So not only the safe failure fraction, but also the probability of failure on demand calculation all take into consideration the dangers detected. And like we said, it can be just as bad and detrimental to you as a safe failure. So when you are choosing a product with a certificate or a certification agency, you want to make sure that they're calculating the safe failure rate for you. You want to make sure that this is something that they're taking into consideration, that you're not going to have spurious trips often. It's not something anyone wants to deal with. So when you're looking at somebody's certificate or a certification body, make sure that they are also listing the lambda S, or the safe failures. So let's take a step back and look at what does the standard say. The standard says that hardware must show compliance via either architectural constraints on hardware meeting the safe failure fraction, route 1H, or route 2H, which we'll explain the difference coming up, and requirements for probability of dangerous random failures, so the lambda DUs, or the dangerous undetected failures. So here is route 1H and route 2H, what we mean. Route 1H is the safe failure fraction, and the next couple slides we'll talk about that. Or for the 2010 standard added route 2H, and this is component reliability data from feedback of end users. And we'll talk about route 2H also at the end. So your safe failure fraction. As you can see in the numerator, you have your safe detected, your safe undetected, and your dangerous detected failure rates. In the denominator, you have every failure rate you have. So your safe failure fraction is the ratio of the safe failures and dangerous detected by automatic diagnostics to the average total failure rate of the system. So it is the percentage of failures that can be considered safe. And this is the 2010 standard. In the 2000 version of the standard, in the numerator you were able to take no effect failures. So things that did not fail, it didn't matter, it was no effect in the numerator also. And because of that, a lot of companies were bypassing and kind of cheating on your safe failure fraction because they were adding extra no effects to get a rise in the safe failure fraction. So to close the loophole of your safe companies cheating the safe failure fraction, they took out the no effect. But in return, this hurt simple mechanical or final element devices. And that's why they added the 2H, root 2H clause. And like I said, we'll talk about that in a little bit. So looking at this, what about the simple mechanical devices? what if you're doing everything you can right? You're proof testing when you should be, or even earlier. You're including leak detection in the proof test. You're doing partial valve stroke testing, but you still can't make SIL 3 or even SIL 2 because of safe failure fraction. Well, that's where route 2H comes into play. You have, what they want is the reliability data and a way to compile all of this to show that you have almost proven in use. You have ways to justify not having a high safe failure fraction for simple mechanical devices. And as you can see here, for 2H, they still are using your hardware fault tolerance for different SIL levels, and there's a chart in the standard, so if you make such a SIL level, you get such a hardware fault tolerance if you comply with all of the 2H requirements. So this is how Exida has compiled the 2H information. We were able to summarize all the data collection to date throughout all of our assessments. We went through component by component. As you can see, this is a little example that I did. It's showing our ball valve components. So we break it down by each piece of the ball valve, each nut, each bolt, each O-ring, anything that is slightly different from the others. We break them out into components, and we total up how many operating hours we have for each component. And this snapshot of this slide should actually be updated. We have a lot more than that now, but this is when we first started. So we have over 100 billion operating hours collected with all of the different types of components. So what happens is we look at a bill of material, and each line item of the bill of material, we see that if that component is 2H, is checked off our list as compliant with 2H, if we have enough data collection on that component. And if every component on the bill of material checks out to be 2H qualified, then the whole device or system is 2H qualified. So that's a way that, because of the way the standard was written, with the safe failure fraction and mechanical devices no longer qualifying for safe failure fraction or failing safe failure fraction, now we have a way to get mechanical devices passed. And it's a complex way of looking at it, but it's a great way to do so. So wrapping it up a little bit, we looked today at how safe failures aren't always a good thing, but calculating them can provide very useful to your company. You can lower your safe failure rate. You can lower your spurious trip. You can make your mean time to fail safe a longer period of time. Also, your dangerous detected failures are just as bad as spurious trips for your plant. We also looked at simple mechanical devices can still participate in a SIL rating, even though they have low or no safe failures by the use of Route 2H, and how Exida goes forward and looks at Route 2H. And finally, if there's anything that you take away from this webinar, it's that we at Exida, we don't want you to get spurious trips almost as much as you don't want them. But if you do get them, please, please, please do not bypass your safety system. There are much better ways to solve the problem. So at this point, I'll take, if you have any questions, go ahead and send them in. And if you're thinking of it tonight or another day and you have questions later on, please write down my email address. I would love to answer any questions that you might have, and any questions that I do get, I'll be submitting to everybody that signed up for the webinar, because chances are, if you had the question, multiple people did, and maybe some of them didn't attend online and they just didn't have time to, or maybe they just didn't feel like asking. But if you have any questions, please let me know. For more of our webinars, you can go on our website under our webinar category. They're all free. We also now have a YouTube channel. On our website, we have white papers that you can look at and blogs. We also have our SAEL, our Safety Automation Element List. And that's a great tool to use. A lot of people use it frequently, so you want to be on it and you want to use it. If you are certified to a level of competence and your products meet the certification, the heavy certification requirements, we will list you on that. So if somebody needs, say, a ball valve and they need a SIL 3 ball valve, they will go to our list. They can filter on this and see all what companies can offer them that. And also you can look at any of our books on isa.org or exida.com. And like I said, if you have any questions, please email me. And if not, I hope you have a wonderful Friday afternoon and a wonderful weekend.